Okay, so we're going to be talking today about scatter plots. So this is the portion that's called bivariate data, and what bivariate data entails is a comparison of two qualitative data sets that have effects on each other. So you guys know them as correlations or cause and effect. When you look in things like science, talks a lot about cause and effect. Social studies definitely talks a lot about cause and effect, where when one thing happens, it causes something else to occur. It's the same thing here with math, that there are situations where when one event occurs, it has an effect on another event's outcome. Okay, so what we're going to be doing today is we're going to talk about how we can construct and describe associations. Okay, so how data is associated or correlated to each other within scatter plots, including linear and nonlinear associations, positive and negative associations, and then the concept of outliers within our scatter plot data. So first thing that we're going to talk about is the different types of variable associations or variable correlations. So when we talk about variable association, what that means is when something happens to X, how does it affect the Y? So it's very similar to the idea of slope. If you were to have drawn this as a straight line, what kind of slope would that be? Positive. So it's the same thing when we're talking about an association, a variable association. What this means is that as your X values are increasing, naturally your Y value is going to kind of go up as well. So let's write that down. As X increases, so does the Y. The Y will increase. And of course, then it has the opposite as well. If X is decreasing, so as you're moving down to the left of that line of the X, you're also moving downward on the Y value. Okay, so as X declines or decreases, then the Y decreases. So it's either double positive or double negatives. And that creates that positive association that's going to occur. And now the idea again of a scatter plot, think of the word scatter. It kind of means it's all over the place, right? It's not really a specific line that it's following. So it's just a relation of data. So when we say things like, oh, if you study more, what should happen to your test grades? It increases, right? But there's not a very specific linear representation of that. It's not a guaranteed formula of, oh, if I study an hour, I'm going to get a 75, but if I study an hour and a half, I'm going to get an 80, and if I study 2 hours, then I'm going to get an 85. There's not that direct relationship there. It's just the idea or the concept that if you study, the more you study, the higher your grade should proceed, okay, up until a cap-off point. Same thing with things like, oh, you know, the more that I eat, the more weight I should gain. But obviously, you know, that's not everybody's going to gain the exact same amount of weight as they're eating. Some people might gain more weight from eating food versus, you know, less weight. So there are associations, but they're not specific slope patterns or constant rates of change that are occurring. So that's why they're kind of dotted all over the place. It's showcasing that it's increasing, but not every single person. So each of these points represents a data, a person or a specific situation that, oh, when it happened at this value of X, it was this value of Y, and so on and so forth. Okay, with our negative association, again, similar concept of what slope would be. The negative association or negative relationship for our variables indicates that as our X is increasing, then our Y is going to decrease. So as we're moving to the right of our graph, we're also flowing down from our graph. Okay, and then direct opposite, as X is going to decrease, then our Y is going to increase. Okay, so those are the different kinds of effects that it has there. And then you've got something called no relationship, no association, meaning that it doesn't matter, you know, what you do, there is absolutely no pattern. It's just all over because they actually don't have a direct relationship with each other. Okay, so we call that no correlation. Oh, where's my little orange? So no correlation or no relationship whatsoever. So there's no patterns, no trends. All right, so that's our variable association. How does one variable affect the other variable? Then we've got linear association. Remember, the word linear means what? Line, right? Straight pattern. So with a linear association, even though the scatter plot is not a direct line, what a linear association does is it kind of follows almost what we could do a straight line with, whether positive or negative. Nonlinear has more of a curvature that is occurring within, or even several curves that might be occurring. Okay, so nonlinear versus linear associations is talking about whether the pattern kind of flows more in a direct path versus more of a curved relationship. Okay, so we would write that down to the side. Linear, somewhat straight. And then nonlinear is kind of curvy. Okay, and then we've got a couple of other things down here. We've got what we call clusters. So with clustering, that's a group of points that follow the same exact pattern that's occurring. So with clustering here, we've got one cluster that's occurring where they're both following a very straight direct path. Okay, then you've got some gaps that are occurring. Your second cluster kind of goes in more of an upward direction, and then your third cluster kind of levels off again. Okay, so again, this would be considered a nonlinear pathway that's happening because you do have curvature that's occurring, but you have clustering where a bunch of data seems to follow the exact same pattern, the exact same sloping until it turns and changes to another clustering. Okay, and then you've got outliers. Outliers are those points in which they are completely standing out from the rest of the data. Okay, so we all know that the idea of studying more is going to increase your score, but we have people who don't study at all and do just fine, don't they? We also have people who study really, really hard and for a long time, and still they do poorly. Okay, that happens. Those would be considered our outliers in our data set. So our outliers, I'm going to go ahead and highlight those in my blue. Those are the ones that they kind of stand off from the rest of the patterned data. They don't technically follow what the situation would be. Okay, and then with our clusters here, I'll highlight these clusters a little bit better as well. So we have our first cluster, I'll do that in the green. Our second cluster kind of followed up here with the blue. And then we had our other cluster, I'll do that in purple. Okay. All right, any questions so far? Pretty simple stuff. All right, let's go ahead and flip it on over to the back. We're going to talk about different kinds of relationships or correlation scenarios. Okay, because it's easy to identify correlations from graphs, but now you need to be able to visualize what those graphs would be from different scenarios that are presented to you. So let's talk about some positive correlations. So I already talked about the one where we say that, hey, if you spend time studying, versus your test scores. Okay, we know that if we've got low times, that can tend to lead to low scores. So people who don't study very much might have lower scores. People who tend to have higher time or more time studying are going to have higher scores. This is really true when it comes to, like, as you're getting into harder classes, older leveled classes, when you get to high school, especially in college, you know, that definitely is going to stand out. The more time that you and effort you put into it, the better results you're going to get. And the same thing with practice too. If you're doing a sport, obviously if you practice a lot, you're going to increase your, you know, agility, your abilities to be able to perform that sport versus those who don't spend that much time practicing. Okay, some other ones, like if your child's age, a child's age versus their weight, right? As a child gets older, they are supposed to increase their weight. That's the goal. Notice I put child's age because it's not true for adults, right? An adult, as they age, can stay the same weight 30, 40 years, okay? So a child, though, because a child is growing, their weight and their height should increase. So when they're young, they're small. As they get older, they get bigger. Okay, so what I want you guys to do is I want you to think of another positive correlation that you can come up with. So take a moment to think of a positive correlation, a positive relationship that you can create. Or who can share one of the correlations that they created? Or a correlation you heard and you thought you might like. Kaden?
Rain and drought.
No. So rain versus drought. So the more it rains, the less there's a drought, right? That's not a positive correlation. Okay, positive correlation means that the more this occurs, the more something else occurs. So you have to, so don't think of positive as a positive situation. Okay, positive situation doesn't necessarily mean positive correlation. Okay, Mason? Okay, that kind of goes along with weight, yeah. So child's age versus height. Eker? Huh? Food versus weight. Okay, we talked about that already. Okay, amount of time you spend in the cold versus sick. I like that one. So if you are outside in the cold a lot more often, you are running the risk of increasing your chances of getting sick a little bit more often. So that's a really good one. All right, so time spent in the cold versus time sick. Okay, so as you are spending more time outside in the cold, your chances of getting sick are increasing as well. That's a good one, thank you. All right, negative correlation. So again, opposite. So what Caden had said, he says the amount of rain versus the drought. That would actually be a really good negative correlation, because the more rain we receive, the less drought we have. Okay, so those are opposite effects, that as one item increases, the other item will decrease. Okay, so if we think about things like when you drink water, the more water you drink versus the amount of water that's in your bottle. If you're drinking water, then the amount of water that's left is decreasing, right? The more you drink, the less water remains. Okay, if we talk about washing your hands, the more often you wash your hands, the less amount of time you are sick. The more you wash your hands, the less often you are sick. Okay, food versus hunger. The more you eat, the less hungry you are. Okay, these are all negative correlations. Again, negative correlation is not a bad thing. It doesn't mean something bad is going to happen. It just means that they have opposite effects, that one increases cause another's to decrease. So I want you to go ahead and think of another negative correlation, aside from the ones that I just mentioned. All right. Who wants to share out theirs? All right, Elijah.
More jobs versus unemployment.
No, that's good. The more jobs that there are available out there, the less unemployment that we have to deal with. That's a really great one. I like that. Let's put that down. That's good. The more jobs that we have available for people, the less unemployment that there's going to exist. Elijah, that was an incredible example. I think you're going to get some pride points for that one. That was really good. Shh. Let's go ahead and do more. Shh. Caden? Okay, yeah, I'm not going to repeat that. Oh my God, Caden.
Less emotions you feel.
Caden, honey, Have you been cheated on often in your life?
Oh my
Okay.
God. Only in Fortnite though.
Only in Fortnite, okay. All right. Okay. Yes, I guess that would be,
That deserves a prize.
that deserves some therapy is what that deserves. Okay. All right, let's go on to no association. No association is things that, again, one has no relation to the other. So I could say something like my arm length versus my math grade. Okay, how long or short arms are has absolutely no effect on your ability to perform math. Okay, another one, and again, you guys can go as obscure as possible, but we're just going to move on. The amount of hair that you have versus the number of siblings that you have, you know, brothers and sisters. Obviously, the amount of hair has no effect on how many brothers and sisters that you are going to have. Okay, so they have absolutely no relationship, no effect on each other whatsoever. All right, let's go on to the next page. So constructing and analyzing our scatter plots. When we are constructing and analyzing a scatter plot, there are a few things that we need to make sure that we are reading through and checking. So we want to know, what does the graph represent? We want to know what kind of relationships are being presented to us. So you do need to make sure that you are reading through and looking at what your axes are labeled as. So your x-axis in this case is the price of cars versus in thousands of dollars versus the amount of miles per gallon that the car is going to have on it. So we are looking at, the more miles that it has, the less cost it might be, like less costing that it would cause for you because it's able to fill up more in this gas mileage. So looking at that information, you're going to answer these questions. What kind of relationship is it? Is it going to be a linear relationship or a nonlinear relationship? What specific points might represent on your graphs, indicating any outliers that you see that is represented there. And then you're going to complete the following phrase. There is a blank association because as x increases, y blanks. So obviously, if there's a positive correlation, when x increases, y should decrease. If there's a negative correlation, when x increases, y should decrease. Okay? You're going to do that for those two problems and for the back, those two problems. That is your assignment for today. We will go over these answers on Monday when you come back into class. This is your assignment, so that's why I'm saying you won't need your computers for today. When you finish your assignment, because you will finish it before class is over, you can then go onto your computer and you can work on any DLD work that you still have missing for my class or for other classes if you have missing work for theirs too. If you do not have any missing work for any of your classes, then you can go on and get onto iReady for math. I would ask you to do iReady math. Any questions? Okay. No, you're not working with partners. You're going to do this on your own because I want to see what you do know. Okay, and no, you're not going to work on the rest of the quiz from last week because I would like to make sure that I designate a specific time for it. We will work on that in class on Monday when we return at the very beginning of class.